Okay, so we got the crankshaft in, it's done as you saw. Now we're moving on to file fitting the rings. On all my engines I like to file fit the rings. I don't like to buy pre-gapped rings. And the reason that is because it's real critical when you put your rings in, 1/1000th difference in your bore. Like if you're honing the cylinders and one bore is 1/1000th bigger, your end gap will be 3/1000th bigger. Now, why is that important? Because if your end gaps are too big, you'll have blow by. And that's one thing we don't want. We want to have no blow by. We want to have as much compression as the engine is designed to have. So basically, first off, when we hone the cylinders, or if we had the cylinders honed, each piston manufacturer, depending on the alloy of the piston, has a dimension that is required to have piston to wall clearance. When you put this piston in there, you would need to have X amount of clearance between the piston and the bore, and the piston manufacturer will tell you that. So when the block is honed, you're going to hone it to that dimension. Now, going back to what I said, if the block was honed and we were to hone it, and one bore was 1/1000 over, say, for whatever reason, that would affect your end gap. So that's why we like to use file fit rings. I already did all the rings. I didn't video that because it'd be just boring. It's just kind of a long, tedious process, but I'm going to explain to you how I do it. And it's real simple. So when I take the rings out of the box, basically what I'll do is I'll put it down here in the bore, and the first thing I'll do is I'll check it. And all I do is I take a spark plug and I cut the electrode off of there, or the strap off, and I'll just do this. This is basically like 3/4 of an inch down in the bore, and I'll square it up like that. You can see how quick that I've done that. Then I'll grab my feeler gauges, and before I even gap any rings, I'll just measure. I'll take a measurement, what it is. I'll take that number, and I'll put it here in my ring filing machine, which I use this Total Seal machine. This thing works awesome. Matter of fact, shout out to my buddy Doug Wagner. He bought this for me as a gift. So thanks, Doug, for that, man. This thing really is a lifesaver because it works really good. So basically, just put the ring in here like this, put it down, and then you just zero it out. And you turn it on, and you go back and forth into whatever number you're trying to get. So for instance, if I'm trying to get to 20 on the ring gap, and when I first checked it, it was 16, I only need to take 4/1000 off of this. So I'll zero that out, and then I'll just do 4 strokes, and I'll move this one line at a time, which is 1/1000ths. And I'll just keep going up and down, and that will give me my 4/1000ths. I'll take it back out. I'll put it back in, just like that. And then I'll check it. And then I'll see if I got my 20. And you should, because that thing is real accurate. But if you know it's like a little tight, and I might take it back out, bring it back over there, and I'll touch it up. After that's all done, I will take a small file. I'll file the edges, and then I'll turn this motor back on, and this is like a little buffing wheel. And then we just buff the edges of it, and then that one is done. So real easy. And then we just go down, we do every single one. Another thing that you got to check, and it's just don't take for granted that these are the support rings for the oil ring. Check these, man. A lot of times, like 89% of the time, I don't have to do anything with them, but there's going to be that 10-20% that you're going to have to. So you want at least 15-20 gap on these. So I'll just put them in there. I'll check it. If they're too tight, then we'll take them over here, and I'll just do it by hand. Because these ain't that critical as far as that goes, but you can't have them buttoned. So always check those. Another thing about the rings is when you put your piston rings on, you'll have a upper, your top ring, and you'll have your second ring, and most rings will have a dot on them, but not all of them. If they have a dot, it's real easy to install. You install with the dot up. Same with the second one, dot up. But if they don't have a dot, and on your first ring, you look for the bevel. And if it has a bevel, the bevel goes upward. And on the second ring, if it doesn't have a dot, and on the second ring, you will look for a bevel, and the bevel on the second ring would go down. So that's real important, man, because if you don't get that right, you're gonna get blow by, especially if the top one, that's the critical one for sealing. The second one is just a scraper ring. It's minimal for compression, but it's important to scrape the oil off. You need to get that right. If the second one doesn't have a chamfer on it, might be what's called a Napier ring. And the second ring will have a little lip on the edge here, and that helps scrape the oil down. You got to make sure you get that right. So the lip would be pointing downward if it didn't have a dot, and that's what scrapes the oil off. Another thing about the rings, when we go to file fit the ring, we will look at what the manufacturer suggests for their ring, for the material that we're using. And for this one, we were using for the top ring 4 thousandths, or 4.5 thousandths times the bore diameter will give you the gap, that's the minimum gap that you're shooting for. So in this case, on the top ring, we're going to shoot for 20, and on the second ring, we're going to shoot for 22. This one is going to be 5 thousandths per bore, so 0.005 times your bore will give you the gap. That's for the second ring, and then for the top one on this particular application is going to be 0.0045 times the bore, and that will give you the top one. So that's it for the rings, and very important, man, because blow by kills horsepower, and then your engine's going to smoke too. You don't want that. So probably one of the biggest things where you can gain horsepower is the rings, and that's why it's really, really important to make sure this is right. So that's pretty much it for the rings. The next thing is what we're going to do here. So this is all done. We're actually going to put the rod on the pistons next, and that is really important too. Basically, it's real easy though. Obviously, the pistons are directional in the bore, and also the direction of the rods are directional too. So let me grab one of these rods here. Show you. So the rods will have a chamfer, heavy chamfer on one end. Okay. And the reason why that is because this chamfer goes on the crank journal, to the outside of the crank journal, and that's a relief for the fillet of the crank, which is right here. Okay, that chamfer is to clear that fillet of the crank. Now when you put these rods on the pistons, real easy, and they're all going to be the same because the engine's symmetrical. It's real easy to do, and this is just how I remember it. So when you're putting the piston on the rod, just think of this. The dome of the piston is always to the outside, okay? And then being this piston here goes on this journal, this chamfer here would be also to the outside to clear that fillet, like I was saying. So when you're putting these on the rods, they will all be the same. You'll basically put the rod on the piston like this, with the dome towards you, and then this radius to the outside. And every single cylinder would be the same way. So when you put it back in, when it's all assembled, you put it in like that. This will be out, and this will be that way. And then say this is cylinder 1, and say we were going over to cylinder 2, I'll show you, it would be the same way also, because this would be going in here like this. The dome would be the outside, and now the chamfer for the fillet on the crank will be that way. So therefore, me saying that, when you put all the pistons on the rods, and we'll lay them up out here when we're assembling them, we'll lay them out. When you're looking at them, so you can just know quick visual, you look, when this is sitting down on the table, the dome of the piston will be out that way, and the chamfer will be facing this way. So when I'm assembling pistons, I'm usually sitting here, and I set my pistons over here. I'm constantly looking to make sure I don't make a mistake. My dome is that way, my chamfer's that way, and they'll all be the same. and you'll never make a mistake if you do it that way. You know, these are just things I like to do. You know, everyone's got their own method, how they do it. But this is just what works for me, and I stick with it. And you know, if you guys got something that works for you, stick with it. You know, but these are just things that I do. I've built so many of these engines. I mean, I've been building these since the '80s, and I just got my method and it works. You know, you learn things over the years, and you just stick with it and keep rolling with it. But anyway, so what we're gonna do now, I'm gonna set all the rings aside, put the machine away, clean the table. I'm gonna put all the rods and the pistons, and I'm gonna put all the rings on the pistons. They'll be all laid up here, and they'll be ready to go in the engine. And I'll probably set the camera up for that, and I'll just let it roll and let you guys watch me do that. So after that, we will move on to installing the cam and putting the timing chain on, and then we will do a video of degreeing the camshaft. So stay tuned. Okay, so we just got done putting the rods on the pistons, and also too, we put the rings on there. And I just want to go over a few things with you guys. So, you know, I sit here when I put in the rod on the piston, and I explain that, you know, I have the dome of the piston facing out and the chamfer facing this way. So when I'm putting the pistons together, I'm always looking this direction, and I'm double checking my work, making sure that I'm doing it right, and that you know, one is not backwards. But so I'm always doing that when I'm building these engines. I'm always double, triple checking my work, so things are, you know, we don't miss something, because it's real easy to miss something. But anyways, so the dome is pointing this way, the chamfer is pointing this way, and when we put it together, we use this high pressure lube, this Torco engine assembly lube. And what I do is I just put a little bit on the piston, on each side of the piston. I put it on the inside bore of the small end of the rod, and then I put a little bit on the wrist pin all the way around. Put it together, and then we put the spiral lock in there. And the next thing is we put the piston rings on. Now this is also important, like I mentioned, you want to make sure the dots are pointing up. So the dot is showing there. I don't know if you can see that, but dot, and then there's a dot there. So the dots are up, and then the next thing is you want your rings, your top and second ring, 180 degrees apart from one another, the gaps. So you put them 180 degrees apart, and then always want to use ring expander. You put the ring in there, and then you put it, you know, you squeeze it like that, and that squeezes the ring, and you can slip it over the piston. Now a lot of guys do it, and I've done it myself, and I still do it sometimes. I'll spin the ring on there without that tool, but I typically do that on pistons where the rings are thinner and they're not as far as down like this. This is a street engine, and the rings are spaced apart more. So you know, we definitely need to use this on this type of piston. Otherwise, you'll bend the ring if you're trying to spin it around. So that's that. And then the next thing we're going to do is we're going to start putting the pistons in the block. And I want to show you a few tools here. The one I like the best, and one you can use, but I don't really recommend. This is an old school one. It's probably like one I had when I first started doing this stuff, and it works. You know, you put an Allen wrench in there, and it's got a little ratchet deal here. But they work, but they suck. I mean, this absolutely sucks. It's hard to use, and in a pinch, it will work, but I don't like it. I don't recommend it. And the next step up from that is this one, which these are pretty good too. These are this old Snap-on deal. And you can use this, put that on there, squeeze it, you know, knock your piston in there. But the ultimate one is one I recommend, and as you can see, I have them on the wall for all different sizes, is these are ARP brand. And this is specific for the bore size that you're using. It's got a taper in here. It's got a notch here if you have an O-ring. If your block is O-ringed, this clears the O-ring. Put that on the block, put the piston down in there, knock it down. Then get yourself a good piston hammer. This was long like this, so you can knock the piston down. You know, I like using that. These are just some of the tools that I use. Again, this is the one I recommend. It goes really, really fast with this too. Can use ring pliers, and that's it. So what we're gonna do is we're gonna put the other half of the bearings in these rods, and I'll put the other end in the cap. And then what I'll do is I'll put the bearing assembly lube in there, the Clevite bearing guard that I showed you earlier. We'll put that on there, and we'll wipe off the cylinders with some trans fluid first. We'll just do a quick clean, and then I'll wipe that out, and then I'll lube each cylinder with engine oil. And then what I'll do is I'll just go right down the line. I'll knock them all in, put the caps on, and then after the caps are on, we'll turn it over, and then we will torque them, and we'll check our rod bolt stretch. So stay tuned for that. Okay, so now we're getting ready to put the pistons in. I'm going to do a few. I'm not going to do all of them because it's repetitive, but I'm going to do one or two, show you guys. So basically, I'm all set up, ready to go. Rods and pistons. I made sure all my dots are facing up. I put the bearing guard on each bearing. I made sure that all the bearings that are labeled uppers are in the rod, and all the bearings are lowers are in the lower rod. The numbers match each cap and each rod. Then I put the RP lube on the bolts, the thread lube, and then this is what I use for the bearings. Bearing guard, the Clevite bearing guard. So it's all ready. Now what I'm going to do is the cylinders, I cleaned them already. They're ready to go, but they're dry. I'm going to put some oil on each one. Squirt it in there, and just wipe it with your hand. Make sure you get everywhere on that. But a good way to clean the cylinders before you do this is with transmission fluid on a clean rag. And the transmission fluid gets out any debris that's probably fine debris that's in the cross hatches from the hone. You'd be surprised. It looks like it's totally clean, and you'll wipe it with trans fluid, and you'll see dirt come off of there. You know, and that helps seal the rings better. So what we want to do when we start this engine for the first time, we want to get them rings seated as quickly as possible. That's the key. Rotate it up. Okay, a little bit ago before we turn on the camera, I checked to make sure all my journals are clean. Just make sure nothing fell on or anything, you know, out of the ordinary. Just make sure they're super clean. And then on the first one, make sure your journal's all the way down. And what I'll do is I'll take the first one, and I'll actually take a little bit of oil, and I'll just have it. Even though I got the bearing guard on there, I'll put a little bit on the journal. But take some oil, put it on the piston. Move it around. Again, remember, the dome is to the outside. Make sure your rings are 180 degrees apart. I already made sure my dots are up, so I don't have to check that. My radius on my chamfer on my rod is out. And then what we're going to do, we're going to take this, slip it on there like that. We're going to guide it down, just like that. Take a piston hammer. And what I do is I always keep my finger on the rod as it goes down and guide it down. So I'm going to tap it down. I'm guiding it down. That's it. Sent it home. What I'm going to do is I got all my rod caps lined up in the positions that they go. So this is 1, 3, 5, and 7 on this side. And I already got them lined up so I don't make a mistake being the wrong ones. So now I'll take this, and I'll take 2 of my rod bolts. Bearing guard's already on the cap. Down there like that. I'll take my battery and pick. I'm just drawing them in. I'm not tightening with this or nothing like that. There actually, as you can see, there's a gap in there. And I'll just leave it like that. And then I'll go on and I'll do the next one. And what we'll do is when we flip it over, after we have them all in, we'll flip them over. I'll actually bring them down by hand, and then I'll mark, I'll check each one with my bolt stretch gauge. I'll write those down, and then we'll torque the bolts. But we'll show you that when we're done with this part. I'll just go ahead and I'll do some with three. Bring it down. Oil on the journal. Make sure you're grabbing the right one. Piston 3 again. I have them lined up and ready to go the right way. You gotta go crazy with the oil. Just enough to get it on there. Line up your rings. This is why I like this piston ring compressor tool so much, because it's so easy. Dome out, guiding it so the rod is straight with the journal. Grab your hammer. I always hold the bottom of the rod again. Three, 2 bolts. That's it. Loose. And then I'll go ahead and I'll do all the rest. And we'll shut the camera off for now. Then we'll come back and then we'll show you the next step. Okay, so it's the next day. We got the pistons in yesterday with the rods, and I just snugged up all the caps, the rod bolts and the caps. And now what we're going to do is we're going to get ready to torque these rod bolts. But before we do that, one of the first things I like to do is check is my rod side clearance. And basically that's just the clearance between the rods. And this measurement really it's critical in the sense that you don't want it too tight. Loose is not going to hurt you. You know, there's been a lot of talk over the years like side clearance dictates your oil flow, and it has nothing to do with oil flow. Your bearing clearances has to do with oil flow. The main thing about this is you just want to make sure that they're free and they move. You don't want them tight. Obviously, if they're too tight, you're gonna wear out the side of the rod and crank, and you're gonna have debris going in the engine. But like right now, I checked mine. Mine's at 25 thou. I would say minimum side clearance of the rod, 15 thou. If you were less than 15 thou, I would be concerned about that, and then I would look, investigate and see what's causing that, and address that. But if you're 15, I would say 15 to 30. That's pretty normal. Even more is probably not going to be an issue. And if it was aluminum rod engine, yeah, more you're going to need more, because the connecting rod being aluminum will expand, and you need to allow for that. But anyways, the main concern is not being tight, and that's what we're looking for. So go over and check all your rods, side clearance, make sure they move, and then you're going to be good. Like I said, 15 minimum. Now the next thing we're going to do is we're going to torque the rod bolts. And then we're going to actually stretch the bolts. We're going to check the stretch. And as I said before, the stretch is critical because the stretching the rod bolt up to where the recommended stretch is going to give you the most clamping force. And it's more important than the actual torque number itself. Now, like I said, they said 64 for the bolts. I figured out 66 was going to get me real close to 4 6/10 of stretch. And I like to get real close to that. Then I know I got the clamping force that I need. Plus, that's when I size the rod bearings in here for the clearance. I put them in here in the rod vise. That's what I use, 66. So I want to use the same thing that I used when I was checking the clearances. So anyways, what we're going to do, we are going to back off the bolt. Like I said, I only had them snugged up by hand. And back this off. There's no pressure on these bolts whatsoever. This is the rod bolt stretch gauge. And what we're going to do here is we're going to find the shortest bolt. Sometimes they're equal, sometimes they're not. And we're going to zero out this gauge to the shortest bolt. So right now, this one's already on 0. So let's check what this one is. So this one is longer. So this one is, let me see here, this is 1, 2, 3 thousandths. 3 thousandths longer than that bolt. So what I'm going to do, I call this one the inner bolt and this one the outer, because the outer one is easy to get to, plus where I stamp it on the rods is always going to be the outer. So we know the outer was 0. I'm going to write that down. And then the inner one is 3. I'm going to write that down. So now what we're going to do, so we're going to torque this to the 66. And we're going to do the sweeping motion like I explained before. One sweep motion. We're not going to do jerk motion or do it once, twice. We're going to go right to the 66 on one sweep. That's it. Okay, now we're going to go back and check our stretch. The key is to be close to the maximum stretch but not be over. If you go over the stretch, that rod bolt is junk and you need to throw it away. It's, you're going to take a chance of throwing a rod, breaking a rod bolt, anything like that. It's not worth it. So be careful when you're doing this, but this is in my opinion, this is the correct way to do it. Doing it torque alone is not the way. This is the way. So now what we're going to do, we're going to go back. So we knew what our number was before. It was 0 before we stretch it. Now we're on 3.5. 3.5. Write that down. Our max is 4.6, so we're good. Then we'll go back over. Now we are at 7. And we had 3. So we're at 4 stretch. I'll write that down. And again, our max is 4,000 6/10. So I was 6/10 away from overstretching it. But that's good because I'm right up to where I want to be as far as stretch goes. And then what I'll do is I'll just, after it's all torqued, just get in the habit of, rotate the engine around, make sure nothing's binding, nothing's hitting, This is when you start checking things like, rod clearance to the block. If you had to put a stroker crank in it, you would check the rod to the block and then you would check at the bottom of the bore if it's hitting. But being this is a 4-inch stroke, in a standard block, even though this was a 427, there's going to be no clearance issues. So that's pretty much it, man, for the crank install. Crank, rods, pistons. Now what we'll do is we got the cam all, cam bearings y'all figured out earlier on. Now we can install the cam. We can put the timing chain on, and then we can degree the camshaft, and that's what we'll do next. So stay tuned. Okay, so now we got the camshaft in the engine, Now what we're going to do is we're going to degree the camshaft. I didn't video putting the cam in because you guys already saw me on part 1 putting the cam in. It's the exact same procedure. So anyways, I put the cam in, the timing chain on, and what we have to do now is we have to put the piston stop on here. And the first thing we need to do is we need to get this degree wheel 0 to when this piston is at completely to the top of its stroke. This pointer needs to be on 0. And the way we're going to do that is we're going to put this piston stop on here. This is just a piece of angle iron that I made. Nothing special. Drill different holes in there for different engines. What this is going to do is allow the piston to come up and touch that. And I'm going to show you the procedure on how to get it to 0. Okay, so the principle of this is pistons, I'm going to rotate the crank till the piston comes up and touches the bottom of this. Just touches. I'm not going to force it or nothing like that. And then I'm going to rotate the engine back the other way until the piston stops. Now the idea of this is so whatever degree this falls on, it's going to be on the same number of degrees past 0 each way. So I'll rotate it right now. Bring the piston up till it stops. Look at the number. It's at 22. Okay. Now, I already did this. I already set it up. So I already know it's going to be right. But I want to show you that when I rotate this back around the opposite way and bring the piston up and touch that, it's going to be at 22 on the opposite side of 0. Boom. 22 on the opposite side. So, in knowing that we're at 22 on each side of 0, when I take this piston stop off and I rotate the engine up till the piston's all the way up, it will be at 0. I'll rotate this around. If you come here and look, put this on 0, and the piston's at the top. I go past it, come back, piston's at the top. I'll keep going, it goes back down. So see how perfect that is at 0? And the reason why we want to do it like this is because the piston actually dwells at the top of its stroke for just a split second. And doing it this way, if you bring the piston up a couple degrees before, rotate the other way a couple degrees after, and then 0 that out when it's off, or put the same number of degrees on both sides of the 0, when you take the stop off and rotate to 0, it's going to be exactly 0. And that's the best way to do it. Okay, so now what we're going to do, now that we got basically top dead center on 0, now we got to do is take this gauge, it's just a dial indicator, and put it in the lifter bore for the number 1 intake valve. Okay, now what we want to do here is we want to rotate the engine so the camshaft, the lobe on the number 1 intake, we want this to be zeroed out at the very top. Okay, and that's what we're going to do. We're going to zero that. We're going to bring the lobe around. It's going up. See, it's going up. Right there. Back it up. So at the top is on 10. So what I'm going to do is I'm going to zero it out. I'm going to move this to 0. I'm going to back it up just to verify. Go back around. Hit 0 and it should go back down again. Yep. Just a little bit. Right there. Perfect. Okay, so now what we need to do is we're going to rotate the crankshaft so the intake lobe goes 50 thou on one side of the ramp of the lobe, and then we're going to write that number down off the degree wheel. Then we're going to rotate it the other way and go 50 thousandths on the dial on the other side of the ramp, and we're going to write that number down. I'm going to do that right now. A little bit past, so I'll back it up and I'll go back to 50. Pump it in. Okay, 50. Okay, so I'm at 154. Write that number down. Okay, now I'm gonna go back around and I'm gonna bring it back around to 0 and go back around again to the other side of the lobe to 50 and write that number down. Right there. We are at 63 and a half. And now I'm gonna grab my calculator. So we'll take 154 and we'll add 63.5 and we're going to divide that by 2. Divide that by 2. 108.75. 108.75. That's what the cam is degreed in at. And I was shooting for 108, and that's honestly close enough. I can fine tune it, but it's not necessary. 108, 109 is going to be good. And that's actually going to be 4 degrees advanced. I put the camshaft. And the reason why I did that is because this is going to be street engine, street strip. And being advanced, it's going to give it more throttle response. It's going to get, right off the hit, it's going to be real crisp, and it's going to have, more low end power when, for a street car you want it. If it's, if it's a race car, we might move it the other way if we want to trying to get power up top. But that's not what we're trying to do on the street engine. So that's basically it on the cam degree. It's real simple. Just put your degree wheel on there, get it to 0, take the piston stop off, put that in your number one where the lifter goes. Go 50 thou one way, write the number. 50 degrees the other way, write the number. Add those numbers together, divide by 2, and that's going to be the degrees your intake or your camshaft is degreed at. Now, if I wanted to retard it, all I would do is loosen these 3 bolts here, and then I would turn this little hex key, and this thing here, these dots are 2 degrees. So what I would do if I want to retard it, I would just turn that to the next dot, and I can get 2 right away, and I would recheck it, and it would be right there. So pretty simple. Okay, so the next thing we're going to do after this is we're going to check the piston to valve clearance. We'll actually throw a cylinder head on there, we'll mock it up, and we'll mock up one lifter and the valve train on the number 1. And I'm going to show you how we check the piston to valve clearance on the intake and exhaust. So stay tuned, that's coming up next. Okay, so now the next thing I want to show you is we want to check the end play of the camshaft. Now, typically we would check this once the cover is on, but I want to show you what you would need to machine with the cover off, and I will simulate it basically. But anyways, we're shooting around 5 thousandths end play on this roller camshaft. We don't need a lot of end play because with the roller lifter on there, you don't need the cam moving back and forth whatsoever. But we don't want it tight, so we want to have a little bit of end play in there. So what we would do is this button here, when the gasket is on here, it's all sealed up and that's all tight. There needs to be X amount of play between this button and the inside of the cover here. That's going to touch that. So what we would do is, if we had not enough play, this was tight on here, what we would do, we'd take this little clip off here. There's a little clip in there, and we could either machine the face of this button, or we could take the whole button out and we can machine the backside, which I already did. This is already set, ready to go, and I already machined the backside of that. Now, if you have too much clearance, what you can do something like this, which I make these shims, like I have marked on there. It's a 7,000 shim. So if you didn't have enough, or if you had too much end play, you would put the shim in behind the button that would go in there, and this would actually be touching the camshaft. So you can play with your clearance that way, or you can machine this surface, or you can machine that surface. However you want to go about it, that's how you would go about doing it. And to check it, what you would do, come around here, Charles. I got this dial indicator set up, and I have this little mechanism here that allows me to change the angle of my indicator. And what I do is I have that actually touching one of the lobes down there. And if this was back, all the way back, I would zero out the dial. And then I would just come in here with the screwdriver, and I would just pry it one way. Like there's 5 thou that way. And then I would pry it back the other way, back to 0. And that would be with the cover on. You would push this so this button touches the cover, and pry it the other way so it goes back, and then it hits the thrust bearing on the back side of the sprocket here for the timing chain. But again, I left this off so I could show you what would need to be machined. Now what I'm going to do, I'm going to take the degree wheel off. I'm going to put some sealer for my timing cover gasket, and then I'm going to put the cover on, tighten it real tight, and then I'll check it one last time to make sure nothing changed, and I'll check it. I'm shooting for around 5. 4 or 5 thousandths on end play on the camshaft is perfect for a roller camshaft. So that's it. We'll take that off, and then we'll put that on. And the next thing is we'll do piston and valve clearance. Okay, so here we're back at the engine, and what we're getting ready to do here is we're going to do the piston and valve clearance, and I'm going to show you how to do that. But one quick thing I want to mention to you guys when you're building these engines, and especially on a race engine, if you've got a custom piston or anything like that, get in the habit of doing this, and I do this on every engine. Put the cylinder head on the engine with no gasket, and then what you do is you rotate the engine over and make sure that the piston doesn't hit the cylinder head. And there's no bolts in there, nothing, and if it comes up and you look, and you just look and see if the cylinder head raises off the deck of the block. In this case, it doesn't. So that tells me, without a gasket, that I already have clearance between the dome of the piston and the combustion chamber, or even the flat deck portion of the piston to the head. That tells me that I got clearance. Obviously, if your piston's sticking up above the deck, then you would need to put a gasket on there and still do the check. But if your piston is 0 or below deck, you can do this, and it's a good indication that you're going to have good piston to combustion chamber clearance. If you're doing custom pistons, this is mandatory. You got to do this check, because you put the motor together and you think you got enough clearance, and this thing you spin up, especially if it was aluminum rod motor, you definitely have some issues, and piston contact in the head, and that will the piston will just explode. So good little tech tip for you guys. I do this on every one. But what we're going to do now is we're going to set up the valve train. I got these spring simulators, and we're going to set it up to check piston and valve, and I'm going to show you guys that next. Okay, so now I have it set up here to check the piston and valve clearance. And what I did is I just put the lifters in the bore. I put a checking push rod in there with the exact rocker arm that's going to be used. And also too, I put a gasket in there. It's not the one I'm going to be using. I actually put a copper gasket in there. And It's the thickness though that I'm going to be using, and I like to use the copper gasket for this because it's already compressed, and I know my measurements are going to be right. But anyways, I just put some oil on the lifters, and I put the check-in push rod in there, and I adjusted it to where I thought it would be close to the correct length. And you can do that by marking the top of the tip of the valve and rotating around. And we'll do that later when we actually measure for the exact length push rods. But for now, this is just for mock-up. So I put the gasket on, I put the head on. I have these checking springs in here. Took off, we don't have the actual spring on. These are just a lightweight spring, so you can push down on this. And then we bolted the head down. It's not torqued, but it's tight. Okay, so now what we're gonna do, I have the degree wheel back on the engine. It's already zeroed out. And we're gonna rotate the engine over. And when you're checking the exhaust valves, the piston to the valve on the exhaust side is typically always closest to 10 degrees. 10 degrees before on for the exhaust, and on the intake, when we go to put this over in the intake, I have it marked here so you can see. Typically the closest is going to be 10 degrees after for the intake. So intake 10 degrees, exhaust 10 degrees before. We're going to be rotating in this way. So what I'll do is I'll back this up, and I usually bring it right down, right to 10 degrees on the exhaust. I'll zero out my gauge, and then I'll hold the push rod down, and then I'll push this down so actually the valve will contact the piston, and that's going to tell me. So that's 100 thou, 159 thousandths. I'm going one full time around, another 50, and 9 more. 159 thousandths. Now, what I always recommend to do, go around 180 degrees, and just to make sure that you have it at the right sequence, because it could be different. You obviously want to get to where it's the closest. So if you had it there, and we checked it again, see how many times it goes around? A few times, so it's on the wrong stroke to be checking that. So it's going around 1, 2, 3. Like that would be like 310 thou. We know that's not right. So you're not on the right stroke. So you're going to bring this back around. Bring back to 10 before. Zero it out. It's 100 thou, 59. 159. So that's what we have right now. 159. Now you can hear the valves touching the piston right there. So that's good, actually. And what you're shooting for on a performance engine like this, what I like to shoot for, and even on a race engine, if you have on the exhaust side 125 thousandths piston to valve clearance, that's plenty. And you can have less on the intake valve. I shoot for around 100 on the intake and about 125 on the exhaust, and that's even with the aluminum rod deal. We could even go tighter on this, but there's if this was a race engine, we could, and I have gone tighter, but it's not recommended. There's some situations where you might only have like 80, and you got to just really be careful when you're doing that, because you got to make sure your valve lash is right, and so you don't have any problems. But if your valve train is good, your springs are good, you could get away with that. But if you want to have no absolute problems, just use the standard number, like 100 on the intake and 125 on the exhaust, and you're gonna be good to go. So what I'll do now is I'll just move this whole setup over and to the intake valve, and I'll do the same thing, except when I check it, it's going to be on the 10 degree after for the intake valve, and we'll do the same check. And if there was an issue, then you'd have to address that. Then you would have to either fly cut the piston, like if you need more clearance, and you'd have to make sure that the deck of your dome of your piston is enough thickness there so you can machine it. You contact the manufacturer of the piston, or you can sink the valve in the head more to get a little bit more. You can do that too. I've done it both ways. But this would be how you would check it, and then after you figure out what you need, then you can go about that way. You can also get a thicker head gasket if you needed to, but then you're going to reduce your compression from what you were shooting for on your original design. So again, these are all things to consider when you're doing that. But what we're going to do now, we're going to take this off, put it to the intake. We'll do the same check, write down the numbers if all is good, and then we can start assembling the heads, and we'll show you that part next. Okay, so now after we check the piston and valve, what we're going to do is we're going to check for the push rod length. And what I did is before I put this rocker arm on here, I colored in the top of the valve with a black marker, just a Sharpie marker. And what I'm going to do is I'm going to rotate the engine over, and I'm going to rotate this wheel by hand. I'm going to show you how I'm going to do it. I'm going to do it when it's at the top of its lift. I'm going to do it midway, and I'm going to do it at the bottom. And then we'll bring it back up, then we'll take it off, and we're going to see where the marking was on the tip of the valve. And what we're shooting for is the narrowest mark, and we want to get the mark center to the valve. So I'll go ahead and rotate this around. I'll turn the wheel like that so it marks the top of the valve. Now as it starts to go down, I'll turn the wheel, and basically what I'm doing is I'm trying to wipe off the marking of the Sharpie. Now it's at the full lift. I'll turn it. As it comes back up, I'll turn it, and then once at the top of its stroke, we'll turn it. Now we'll take this off, and we'll look, see what the marking looks like. There you go. So what that's telling me, it's really close. I'm just a little off center, but the width of it is really good. So my push rod is a little bit too long. What I'll do is I'll probably shorten this push rod about 50 thou. And then what I'll do is I'll color this back in. I'll put the rocker back on. We'll do the same check. And then what I'm shooting for is that marking to be dead center of the valve. And that's what we'll do next. We'll shorten that up, remark it, check it. And then once that's right, then we'll take this push rod out, and we will measure the length with our calipers. We'll write that number down, and then we'll go and we'll see what's available from the manufacturer for this length. And I've been buying Manley push rods for these street engines that work really, really good. So that's what we'll do. We're going to shorten this up, redo it, measure it, and then we'll do the same thing for the intake. And once we know our lengths, we'll get them on order. Okay, so now we got the piston and valve figured out, and I ordered the push rods. So the next step is I put the oil pump on. But what you're going to do, this is a brand new oil pump. You just don't want to just throw it on there. You want to take it apart and clean it. You always want to clean the parts before you put it on the engine, because if there's any debris in this pump, it's going to go right into your main bearings like instantly. So I already did it, but I'm just going to explain to you what I did. I basically just took these bolts off, take it apart, clean it all, and then put it back together. But before you put it back together, I oiled all the gears and the shaft before I put it on there. But one other thing I want to point out to you guys that you need to check, and this happened to me a couple engines ago. I put a pump on like this, and the surface between the main cap and the pump, it had like a curvature in it, and I could fit like a 20 thousandths feeler gauge in there. So what I had to do is take it back all apart, and I had to lap in that surface on the pump, and get it flat again, and then and then it worked out good. But if you don't do that, you're basically have an internal leak. You're gonna be pumping, and it's gonna be coming out, and obviously you don't want that. But so pay attention to what you guys are doing when you're doing this. It's all the details. The details matter when you're doing this kind of stuff. So look out for that. Clean the pump, oil the pump up, put it on. Then the next thing you want to do is you're going to want to check the distance from the block to the pickup, and we're going to measure the pan, and we need to at least have about like a 1/4 inch gap minimum between the bottom of the pan to this pickup. So what you do is you just take a straight edge, we go like this, measure this, it's exactly 8 inches. And then what you do, take the same straight edge, you put it across here, and you would measure, and it's like just a little bit like 7 3/4. And come check this side, make sure it's the same. 7 3/4. So we got a quarter already, which is perfect. But then we're gonna have the gasket on there, which will probably be like another 1/8 inch. So, you know, we'll have like, you know, a little bit over a 1/4 inch of, you know, 3/8 of an inch gap there, which is absolutely perfect. So check those things out when you put the pan on. Then the final thing is what you do with these pans before you put them on is you want to pre-fit the pan on there. You want to make sure all your bolt holes line up. Sometimes I got to die grind a hole because when they stamp these things, you know, the bolt won't go in. You know, when you put your sealer on there, you want to be able to put your bolts in easily. You know, you want to be fighting it, especially if you got sealer on there. But sometimes I got to do that. And then another important thing that you need to do, you need to put the pan on without the gasket. Just like we did the cylinder head rotating the piston, we're going to rotate the crank with the pan on, just with a few bolts on there. And we want to make sure nothing rubs on the crank to the pan. And this is where on this particular pan, it will want to rub here sometimes. And ask me how I know, because this has happened to me. This right here sometimes needs to be bent down. It's like a scraper inside built in the pan here. And if you have, you know, we probably won't have no problem with this crank because it's a 4-inch stroke. But if we put in a 4 1/4 inch stroke and build like a 496, then the crank is closer to this, where the connecting rod is, and this is where you're going to have a problem. So what we're going to do is we're going to bolt it on there. I'm going to rotate the engine, and if it hits, it's probably going to hit right in here. And all I would do is just take a mallet and I would bend this down, and then put it back on there. Rotate the engine. You know, put your ear on it here if you can hear it scraping, and you'll be able to hear it for sure. And then when you do all this modifications that you're doing, grinding that, make sure you take the screen out, clean the pan real good, put it all back together, make sure it's super clean before you put it on the engine. And the last thing I want to mention about putting the pan on, the reason why I actually put the pan on now at this stage is kind of important too. A few things. I like to put the pan on now before I put the balancer on, so I can get up here on the front of the seal and I can make sure that this is sealed good, because sometimes this wants to push out. And I also like to fill the little gap with sealer, with the Right Stuff sealer, and I'll just take my finger and I'll smooth it out real good. If you have the balancer on there, you can't really get in there good. It just makes it harder. So I like to do this step now, and then after that, then I'll flip the motor back over. I'll put the balancer on, and then another real critical thing that you need to do, and it's very, very important, especially if you have a nitrous engine, you got to make sure that this pointer is dead on zero. When you got top dead center of the piston, we're going to make sure this is on zero, and we're going to adjust that. And we'll do a video on that later, but I'm just kind of touching base on that now. But that's the reason why I'm putting the pan on now. Put the pan on, the balancer, we'll flip it over. Then we'll put the stop back on the piston, and then we'll adjust this on zero. But I'll show you that procedure next. But anyways, what we're going to do is we're going to fit this pan. Then I'm going to just put like an 1/8 inch bead of sealer around. Put the gaskets on, another 1/8 inch bead of sealer. Bolt the pan down, wipe out any excess, and that's done, and it ain't going to leak. You get no leaks. You don't have to put a ton of silicone, any kind of sealer, nothing like that. It's an 1/8 inch bead, and it will definitely seal. So we're going to do that right now. And then when we get back to put the balancer on, we'll do a video on that. So stay tuned. Okay, so we're putting the oil pan on. As I mentioned, we're going to pre-fit this oil pan. And already we had to do a few modifications. And this is something that you guys should do before you put your sealer on, because you'll be wiping all the sealer back off and starting over. But anyways, we had to massage the back of this pan. You can't really tell, but this back part was hitting the oil pump. So we slightly massaged this, bumped this out a little bit so we can move the pan forward. And then most of our holes would line up. But then what you need to do is start putting all your bolts in. And there's always going to be 1 or 2 or 3. You know, there's always a few that don't go in. They're just, the holes are slightly off. And I marked this one. You can see this one's slightly off, and I marked it with a black Sharpie. And we're actually going to die grind that hole just a little bit bigger. Then on this side, we have 3 of them. There's 1 there. There's 2 there. You can see they're slightly off, but what would happen is when you have your sealer on there and you're trying to fit your bolts in and you're trying to go relatively fast because you don't want the sealer to set up, and you're going to be fighting it with that bolt, and you'll never get it in, and it'll just become a mess because you have the sealer on there and you'll be trying to get it in there, and then you're going to end up taking the pan off and wiping it all off. But anyways, just a quick video, just things to watch out for, and we'll get this pan on and then we'll move on to put the balancer on. Stay tuned. Okay, so now we're getting ready to install the harmonic balancer. And I got this balancer here. This is a Summit brand one, and it's actually pretty good for street strip build. I've been using this one for quite a while now. It's pretty good because it has degrees on it, which you would need, and it's pretty economical. It's a good quality piece. I don't know who makes it for them, but it's decent. And if this was an all-out race engine, we would use an ATI balancer, that or Innovators West. Those are the two I would use on a real high-end build. But for these street engines, this one works real good. So what we need to do now, we need to have a press fit for this, but we don't want this to be too tight. What we're going to shoot for a big block Chevy, we want to have 7/10 to 9/10 press fit on this. So what we're going to do, so all you do is just take your, just like you would do your crank and micing for your bearings, measure it. I like putting this little vise. And then zero out your gauge. And then you want to check where you're at. So we want to open it up a little bit. So we want to take probably like 5, 6, or 7 out of this to make it so it's a nice press fit. And what you can do if you don't have a hone, you can use one of these ball hones on a drill. Take WD-40, put it on there, put a little on there, and just run it in and out, and just keep checking it, and it will work. We do it like that all the time. And then you just keep checking it until you got 7 to 9/10 press fit. Another thing you can do is you can heat this up too. You could take a heat gun, heat this up, or even you could even take a torch, or you could put it on a hot plate to about 200 degrees and expand this, and then it will go on really easy. Now what you got to be careful for when you're doing that is, say for instance you have more than 7 to 9/10 press, say it's like 1/10 or more, you got to be careful when you heat it up, because you go to put it on there and then that thing cools off, you'll never get it off. It's going to be super hard to get off. So that's why you want to keep it just under 1/10 press so you can get it on and off. So just keep that in mind, guys. Simple deal. We're going to do it right now. We're just going to spray some WD-40. We're going to go in there and probably take about 5/10 out, and then this thing will go right on. Matter of fact, I actually got a tool I want to show you too, and this is what you need. You cannot be hammering on balancers. Do not ever never bang on a balancer. Basically what you'll do, you'll take that, screw that in there. I actually sawed a slot in there so that way you can, if it gets stuck, you put a screwdriver on there and you can take it out. So this is a balancer installer for you guys that might not know. And what you do is you put your balancer on there. You go on like this. You put this bearing on there, washer, nut, tighten it down, and that pulls that on there. And that way you're not banging on the crank. If you bang on the crank and you put this on banging on the crank, what you're doing is you're directly beating on the thrust bearing. And you don't want to do that. Again, like I mentioned before, the thrust bearing is real critical. If the thrust bearing goes out, all that material goes through the engine, goes in the main bearings, and then you'll be kicking bearings out of it. But anyways, that's the tool. We're going to get ready to hone this out right now, and then stay tuned. We'll come back and show you what they're done. Okay, so we have the balancer on, and now what I want to show you, what I talked about earlier, is how critical it is we need to get our pointer for our balancer. We may have to make sure that's absolutely correct. And but then the reason for that is when we go to time the engine, we need to know that it's perfectly timed. And that's why it's really important when you have a nitrous engine or any power adder engine for that matter. So it's real critical to know where your timing's at when you're spraying nitrous or you have a boosted engine. But it's very important too, just for an NA engine. We want to make sure that our timing is right. So it's the same principle as if we had the degree wheel on there. But there's one little difference on this. We have degrees before top dead center on the balancer, but we don't have degrees after top dead center. And I'm going to show you how to mark this so you can set this up and be accurate. So what I'll show you, I got the piston stop on here. I'm going to rotate the crank till the piston touches. Okay. Now my pointer is at 21 degrees. You look, it's at 21. And what you do is you take your calipers and you measure from 0 to 21, and it's 1 inch 340. Put your calipers back on 0 and mark it on the other side of 0. And I already did. I marked this and I scratched it. So I did it for 21 and I did it for 22. So I got 2 marks there. And it's perfectly accurate because you're using these calipers to do it. So now what you would do with the same principle, is that we want to be the same number when we crank the engine one way and the piston stops. We crank the engine back the other way and the piston stops. The number's got to be equal on both sides of 0. And therefore, when you take this stop off and you rotate this to 0, it would be at top dead center. It would be perfect. So now I'll show you. It's at 21 before top dead center. Crank this till it stops. Now I already set this, so I know it's going to be right. Boom, if you look, it's right on my mark, in line with my mark at 21. And I did it by measuring with the calipers from 0 over. It's that simple. So now, if I take this off, I'll just show you. When I bring this around to 0, the piston will be perfectly at the top. Right there. This is at top. Now we know that's perfectly set at 0. So when we go to time the engine, we know it's going to be very accurate. That's it for this part. The next thing we're going to do, we're going to start assembling the cylinder heads, and stay tuned for that. Okay, so that was it for doing the timing pointer for the balancer. Now the short block is done. The next thing we're going to do is we're going to start doing the cylinder heads, and that will be part 4. So stay tuned for that.